Hi, my name is Shivam Garg. I'm a fifth year PhD student at the CSRC. Today I'll talk about a mobility and congestion aware routing protocol for UAV networks. My advisors are Professor Sunil Kumar and Professor Alexander Eiler, and this project is funded by the US Air Force Research Laboratory. Airborne networks are self-configurable, decentralized, and highly mobile networks. They must satisfy the dynamic quality of service requirements of latency-sensitive flows. This includes high flow throughput and in-time delivery. Some of the existing applications of airborne networks include commercial and goods delivery, urban coverage and surveillance, and disaster management. There are a lot of different communication challenges, especially in a decentralized airborne network. For example, due to high node density, nodes can interfere with each other's transmission. This causes packet collisions and leads to high congestion in the network. When there are multiple flows in the network, some nodes can serve more than one flow. We call these nodes hotspot nodes, and they experience very high congestion. If a node generates data at very high rate, it may require simultaneous packet transmission over multiple interference-free routes. However, in airborne networks, it can become very challenging to find interference-free routes. Due to high node mobility, link breaks frequently, which causes packets drop. So to address all these challenges, we have developed a mobility and congestion-aware routing protocol, which we called MCA-OLSR scheme. This is a variant of a proactive routing scheme called OLSR. The main features of our proposed MCA-OLSR scheme are as follows. The first one is robust route selection. So in this, we first find all the routes between a source destination pair, then we remove those routes which are soon to expire or which can drop packets due to their high path latency. Then the least cost route R star is selected, which considers the hop count of the route and interference in the one hop neighborhood along the route R. This improves the packet delivery ratio. The second feature is preemptive route switching, which addresses the changes in the network topology or traffic and ensures uninterrupted communication. So whenever the route quality of the currently being used route R star degrades below a threshold or a new better quality route becomes available, we would want to switch to a new route. The third feature is proactive queue management. Here, packets with a low survivability score are prioritized for transmission. So as a result, fewer packets are dropped due to expiration, which improves the packet delivery ratio. We also identify and remove packets which are likely to expire before reaching the destination node. This reduces the resource wastage. The performance of our proposed scheme is compared with the standard OLSR. This considers only hop count metric in the route selection, and multimetric OLSR, which considers normalized values of hop count, route lifetime, and route capacity. In the first plot, we have shown the comparison of instantaneous PDR versus time. Our scheme is shown in solid black color, and as you can see, it consistently gives a superior PDR value as compared to the remaining two schemes. We observed a similar performance for other node density and other node speeds and number of flows as well, and data rates as well. In this figure, we have shown the performance of average PDR for all the three schemes at different node densities, at different node speeds, and at different number of flows. Overall, our proposed scheme gives up to 149% higher PDR as compared to the standard OLSR and up to 50% higher PDR as compared to the multimetric OLSR. And this is significant because at high node speed, most of the schemes perform very poorly. We observed a similar trend for other settings as well. The problem with our scheme, however, is it has high control overhead. And high control overhead means less time for data transmission. So in our current work, we are trying to minimize the control overhead and trying to improve the PDR. Thank you.